All right, this is the primary interview process. The purpose of these interviews is to check up on every subsystem team and make sure that there are not any holes in their research and design within the model-based design timeline. Today we're with the environments team led by Jimena. Jimena?
Hello. Hi, how are you guys? So my presentation is on the environmental factors that our cube satellite will have once it's up in space and when we plan for it to come back. And wow, research for this has been really interesting because there's a lot of factors that could lead to damage left over from past satellites, past missions that can really irritate our spacecraft. So, did you want me to share my PowerPoint with you?
Yes.
That'd be perfect.
How do I share?
So in the bottom of the screen, you'll see in the bottom left there'll be there's black buttons. The third one from the left, you click Share Content, and then you can click your screen.
Sorry, now. Oh my gosh. How do I? Now I don't even. Oh, wait. Okay. Welcome. Okay. So our first objective, I wanted to talk about once our satellite reaches space and is able to receive data from the light of stars, we're going to need a safe way to bring it back and not have leftover debris, like I previously stated. So a couple of risks that we have in space is once we are in LEO, there are some phenomena that can damage our spacecraft, and some of these risks have to do with orbital debris. There is plasma that there's atomic oxygen, ionizing radiation, and atmospheric density. And all of these play different parts on different problems that we could face. They range anywhere from mechanical, physical, electrical, to optical damages that we could possibly see once we're up there. And all of these things have to do from our natural space environment. Excuse me. Like for example, solar radiation. If we have too much of a sensitive wire, it could possibly cause a fuse and a short circuit to basically die out. There have been a couple anomalies that I've been able to find from previous NASA spacecrafts, and a lot of them I want to say are about the same what is the word? Damage. I believe there's a lot of power on resets. There's a lot of false flags from the star sensor, false commands, power downs, status changes, failures and upsets, and like I said, short circuit. So assessing this possible damage in LEO. So since there could be a lot of damage that can be caused in LEO, we want to be able to create a pretty good shield and pretty good material that covers our wires so that we can kind of deter any type of damage that can be done within our CubeSat. So I was personally thinking, I'm not sure if we're going to be able to have access to a vacuum, but it would be nice if we could. And I was personally just thinking of like launching things with like a rubber, like almost like a what is the name? It's like one of those like launch things, like a catapult, but like with the rubber bands and stuff. Because most things in space have been known. There are about, I believe, 7,000 orbital debris in space that are greater than 10 centimeters. Anything less than is around tens of thousands. So that's kind of a big thing. I was looking into plexiglass because I know plexiglass is like kind of like almost unbreakable. But the thing is that plexiglass can be scratched very, very easily. And it is a very almost, how would I say it, like a softer version of glass, but I wouldn't want to send glass up into space. So okay, so from looking this up, there's the what is his name? What is his name? I believe his name is Anthony. I don't know how to say his last name. Sorry about that. But he was the first one to create uh, an aluminum shield a good while ago. Oh, it's called a Whipple shield, and it was made by astronomer Fred Whipple. And basically, he created this to protect the their oh my gosh their operational not satellite spacecraft from any orbital debris. And from what I read, especially from NASA, they found that using aluminum and coating it with gold was actually the best type of protection, but the most costly way to go about it. So they found that using aluminum and layering it just a couple more times with copper was actually a really good way to protect their spacecraft from any type of orbital debris that could be found when they're in LEO. So one thing that I really have been looking into, and this has been the past couple of days, but I found a little more information because I was thinking um, maybe the use of less metals and maybe wood would actually help, even though wood is dense, um, and you can't really, I guess, like weld wood. It's a different way of processing this type of material to fuse it together. Um, Wood wasn't really the best material that we could use, but I did find a good amount of information on bamboo, and it's sort of been tested on a structural frame for positioning. But the only problem with bamboo is that it is a very temporary um, solution for, I guess, a more long-term project. So something that we would have to do with that is a lot of test and error. So, and as stated previously, the best materials that are cost productive are aluminum, and it's been seen that a couple layers of copper helped it give a good amount of protection for our satellite. In reference to wires, I wasn't I wasn't able to find enough information on how to protect them from solar radiation and cosmic rays that could that do happen in space. But I have no doubt that our electrical team will be very persistent with the issues that could possibly arise and find a good way lead themselves in the right direction to have minimal failures in our CubeSat. So in conclusion, a solution to help our natural environment and protect the lives of people on Earth would be to minimize the amount of debris that will be left behind. Oh, I did not finish that. From our CubeSat. Basically, there's been a lot of studies that when there is orbital debris up in space, there have been a couple times when a satellite was had collided with another satellite, a Russian satellite that had been left behind in space. And this causes more debris to be left over, and this actually doesn't really what is the word? It does not. Sorry, I'm there. And this does not have any. Okay, I forgot the word, but basically, my point of what I want to say is that it could cause future problems for future space missions. The more debris that we leave behind on every mission prior. So good. A really good actually article that I had read that I had not mentioned on my PowerPoint because there wasn't enough information behind like the materials they used and things like that. It was more of their mission, their completed mission, and they kind of had the things for sale, if that makes sense. It was made by a couple of scientists in Italy. I believe it was called the D satellite, the DQ. And and it actually it had I believe it had a sensor on it. It's a smart propulsive device, and it basically decommissioned the satellite, and it also helped for re-entry into our atmosphere, so that they were like pretty positive that it did not have any leftover, not residue, debris left in our space environment. Because there was a lot that I just felt like would have been a lot to put on a PowerPoint. All my notes are here. Do we have any questions?
Yeah. So you had mentioned using. Oh gosh, let me close this. You had mentioned using copper wrapped, not wrapped, or extra layers of copper around the aluminum. Can you touch a little bit more on the purpose of that?
Yeah, so basically the copper is supposed to protect the aluminum from any orbital debris that could collide with it.
So what does that do for re-entry? What does the copper protect the aluminum from extensive heat?
Yes, it does protect it from extensive heat, but it also makes sure that say something greater than 10 centimeters. I want to say we're gonna say like 90, like something of 90 kilograms. Yes. Were to collide.
Big boy.
We don't want that. Yeah, we don't
90
want
kilograms. That's heavier than
yeah,
the average male.
I know. No, I know. But that's the thing. Like there are so many bigger things left in our space that you never know. And hopefully it doesn't happen. I mean, we're gonna assume they normally like projectile like where we're gonna be, but say something like that were to collide with us. Okay, maybe that was too big.
Okay, hold on. So Are you looking at measures to protect our satellite, or are you looking at measures to protect the environment from our satellite? I think that's what's the reference frame you're conducting your research in?
Both.
Okay,
Both.
so
Because the more we
go ahead.
Because the more we protect our satellite, the less debris that we leave behind in orbit. Because there was a study done that basically stated that some debris that had been left over was actually able to fall back into Earth, and that could potentially hurt people.
So, are you aware that NASA actually requests that we state that our satellite will fall back to Earth?
Yes.
So, why should we put copper on it if NASA says that we need to guarantee that nothing makes it through Earth's atmosphere to the surface? If it protects it from heat,
Yeah.
the heat-resistant copper layer, how are we going to prove to NASA that that's going to not make it to the surface of Earth as a speedy metal cube projectile?
That's a good question. Basically,
Okay, so let me help you out here. So don't worry too much. Don't worry too much about the protection of the satellite from orbital debris in space. That's something that's kind of one of those things where we can't control it, so we're not going to try to control it. What really needs to be focused on is we need the satellite to burn back up at the end of life.
Okay, sorry, continue. No, continue.
There are a lot of new equipment pieces out there made specifically for nano satellites that I'm sure you're aware of for re-entry. There's like a parachute. It's just a tiny little deployer, and it's like a folded up. I think it's a aluminum alloy type parachute that just catches the light particles of air as it slowly kind of descends it back to Earth's gravity. Some CubeSats add thrusters that push it back into Earth's orbit but as long as it's in orbit, it's going to be a functional satellite. And what's going to stop it is actually the atmospheric drag that actually slows down its speed until it starts hurtling towards Earth, at which point it needs to burn up. So what do you propose? Should we include an orbital re-entry device? You mentioned the bamboo. I wasn't really sure. Like, what are you proposing to keep our satellite environmentally friendly?
Okay, well, basically, aluminum won't really burn. It'll kind of just melt, unless it's like met with very high temperature. But I know that our atmosphere, I believe, is 120 degrees Celsius.
That's hot.
Yeah.
That's hotter. That's hotter than what our satellite needs to. That's hotter than what the satellite gets tested for. The satellite only gets tested up to positive 80 degrees Celsius, which is when it's closest to the sun in its orbit or in low Earth orbit. So, and I think aluminum's melting point is below 120, if I'm not mistaken. So basically, what I'm asking, do you think we should add a re-entry device onto the satellite? And if so, what do you think would be the best method?
I want to try.
No, I take it back. I'm sorry. 660 degrees Celsius is the
Yeah,
melting.
I was gonna say it's a lot higher than that.
Way higher, way higher. I'm wrong.
Yeah, so, but the thing is that aluminum is kind of the only material that would protect us. So to be able, so when I was doing my research on the environmental factors, I had to look into all of the things that could possibly happen while we're in space. And then on the way back, like what would happen if aluminum burns in, like, once it's re-entering from Leo? Well, the thing is that aluminum doesn't burn until 600 to 660 degrees Celsius. So, and to be able to use a different metal, I feel like would be very counterproductive in our um, experiment, just because it more prone to a lot of more damage.
I have a quick question.
Yeah, so
No, keep going.
ask.
I didn't mean to interrupt.
It's okay. You can ask your question.
No, hold on, let me turn off my. Okay. I see that you're obviously. I know that you're focused. You're like you said, you're focused on two things, right? You're focused on the protection of the satellite from debris, as well as environmental friendly ways of disposing of our satellite. Am I correct in that statement?
Yes.
Okay. We do have to burn up the satellite. The only thing, maybe what I should, maybe really interested in the environmental side of things. I think the debris thing we get, but if you really want to focus on environmental, I might suggest maybe looking into how we can make our manufacturing of the satellite greener. That makes sense. Like from the beginning, like so maybe instead of like release these certain gases, maybe like cleaner materials to even use or resources to use to build a satellite. Does that make sense?
Yeah.
Another thing too is a low melting point. Find materials with low melting points. I just read an FAA article saying that the re-entry temperature is 2,000. No. It's 1,477 degrees Celsius is the average re-entry temperature of a satellite. So, I mean, aluminum. I think we said was what 660, and this is 1,400. So aluminum, we already know, is going to melt in the atmosphere. So it's just a question of, what materials can we use to make sure everything doesn't make it back to the surface of the Earth. So Diego said choosing cleaner materials, so we're not using, materials that are not made environmentally friendly. That could be something you can look into.
Exactly. From the beginning.
Also look into making sure everything has a low melting point. So that nothing could potentially get through. Because if you have something in the very center of your satellite, right, you have something right in the middle. Well, if it's surrounded by all this stuff out here, first it has to burn through all this, then it has to burn through everything else, and it's got to burn through this, which has a high melting point. It's a little piece inside the middle of the satellite. So you want to I guess check with all the sub teams or do your research and find out all the components listed and see their melting points and do a little chemistry workout. But that leads me into my. Go ahead, Diego.
Yeah, kind of like, because I know you're interested in like, for example, cars and car manufacturing. For example, disposing of a car, we want that to be nice and clean. We want to dispose of a car in the junkyard, let's just say, in a green way, so that we're not disposing of it into the water or any chemicals into the waters or into the ground. That's fine. Building the car in the first place, manufacturing the car, is also a big be a very big environmental concern. So also figuring that part out. Does that make sense?
Yeah, no, I know exactly what you're talking
Yeah. So those two things, I think that would be awesome. Again, it would really help our case if you can find those two, maybe ways to tweak those two aspects, the beginning and the end. It would give us a good case for NASA, because NASA is obviously, in a sense, they are concerned about the environment. I mean, NASA's mission.
Yeah, they've been trying to find.
Yeah. So, go ahead.
Another thing that's clean, quote unquote, is 3D printing, because it's not a metal; it's a piece of plastic. And I know there are a lot of plastics out there that are considered more green to use plastics. And even if it's not a green plastic because it has toxic chemicals in it, it burns quicker than a metal does. So it might be higher up in the atmosphere, so it's not so close. So look at those different things, see what you can get for trade-offs. But the next thing I have is, are you aware of the orbital debris mitigation compliance that we have to reach for every single CUBE satellite and what we have to fill out?
Not for every CUBE satellite, no.
Okay, so it's what's called an ODAR report, and that's something that your team is going to have to figure out. But basically, you've seen the CubeSat 101 document, right? Have you taken a look at it?
Yes.
Okay, so definitely write down pages 54 and 55 and pages 69, 70, and 71. Those are your pages for your team. Looking at those documents and understanding what it is that NASA is asking of you to provide in your research is going to be critical to kind of direct where you need to start doing more research when it comes to the secondary interview process. Definitely write this manual down as well. It is the NASA-STD-8719.14A. That's going to be listing your orbital debris standards. That's what NASA STD, NASA standard. It's the NASA standard 8719.14A. That's going to be a document that you're going to be looking at for the standards that NASA has for all of its satellites in low Earth orbit and other orbits as well. So look at those documents. That's probably going to be a big direction pointer for your team to do more research from now until September. But that is something we have to include in our proposal. So if you can get that, I know that the ODAR sheet is not going to be hard. All you need is a list of materials from the sub teams. Get an equipment list, and then it's not going to be a hard template for you. It should be really easy. But just read the NASA standards, that NASA document. And if you read the standard and then try to find a way to optimize our satellite based off of that standard, I think we can get brownie points that way. Okay.
Yeah.
Okay. So definitely also look into your research about reorbit or re-entry equipment, and if it's necessary, or if you think that the natural atmospheric resistance will be a simple method for re-entry. Because if we're going to be in low Earth orbit, and most satellites have a re-entry of anywhere from 6 months to 2 years. So if we might not need a re-entry method if we know our satellite's going to burn up. But so then now you got to look into, well, why are people making those re-entry devices? Is it crucial that we actually have that device? How much do these devices cost? That's another direction you should probably take your team to research.
Man, I have a quick question.
Yes.
So I kind of lost you a little bit on the bamboo part. Materials. Can you elaborate on that just a little bit more?
Okay, so basically, the research that I had made on bamboo, because bamboo, I know on Earth, has been actually proven to create like pretty good structures. It's very strong, it's very reusable, and when I was doing this research, I had looked up, can bamboo be welded? And it's like a different type of welding almost. It's not something that you just like drill a hole in or like light on fire. It's kind of more like used.
Right. Whatever the
Say
technique is.
you have like a circle of bamboo, you would cut it like in half, long ways, and you would use that to fuse. I believe you, if I'm not mistaken, I believe that you
Is it like a weaving method or?
Is it like a weaving method? No, it wasn't a weaving method. I actually do believe that it was able to. I don't remember how hot
Right.
it has to get.
Well, the reason why I asked is continue. Sorry. I said continue. Sorry about that.
No, what were you gonna ask?
No, I'm saying the reason why I bring up the bamboo thing is because NASA is very strict on what type of materials we can use. For example, one big thing that I learned about at structure team lead was outgassing, and it's partly why we have to bake our structure, right? Just to eliminate any. I mean, you can call them fumes, I guess, but that are embedded inside the structure. So it's interesting that you brought up bamboo. I was just wondering if if it is allowed by NASA to be used in the vacuum phase environment. I guess that's what I'm asking. If so, that'd be very interesting, honestly. But if not, then we really wouldn't be able to use that at all, because they wouldn't even allow us to even launch with the material on board. Make sense?
Yeah.
So I'm seeing your team. Right. Go ahead.
Well, I know that NASA had looked into studies about sending plants to Mars, I believe. One of these plants was actually bamboo. And that's because bamboo can actually clean the atmosphere.
Right, but the thing is, we're not
Yeah, it's not. Yeah, I see what you
exposed to
mean.
vacuum.
It's not an actual like structural thing that is being sent and then burnt up.
Listen, if you want us to ask NASA that question, let us know. But you just got to be a little bit more specific with your question. So,
Okay.
instead of saying like, "Can we send bamboo on the satellite?" Well, that just sounds like we're gonna hunk a piece of bamboo in our satellite and throw it up there. So
Yeah.
you got to be a little bit more specific. You got to say like, "Hey, can we use our standoffs as bamboo pieces, or can we use bamboo wood as the platform for our layers and our satellite to put things on?
Yeah.
We use bamboo as a reinforcement pole that the standoffs stand on. Like you got to be a little more specific with your questions, and we can ask NASA. They answer when you talk to them. So I just sent you a text message. It's a free software of Orbital Mitigation provided by JSC, which is, I'm not sure what JSC stands for. I just looked it up and I can't remember. Anyways, it's a software provided by NASA for CubeSat developers to detect orbital debris and orbital debris mitigation techniques. I suggest you get acquainted with that software. Also get acquainted with AGI, because I believe AGI has a re-entry kind of software system you can use to understand how it's going to re-enter in the chemical properties based off of the .mdl file provided by the structures team. So definitely look into those, and if you can, provide some information that you find from the software in your next interview in early September. But I definitely think that you're going in the right direction with your research. Just narrow down your questions, and if you have the questions, ask them. If you're thinking about things like using bamboo for certain components, ask us and we'll bring it up to NASA. Okay.
Yeah.
Okay.
Awesome.
Anything else?
Any questions you have?
No, I don't have any questions off the top of my head. What I did want to say was, in reference to bamboo, questions that I actually had in regards with that, for structural purposes. I did see. Okay, so my question starts off: could we use bamboo as one of our structural frames for the positioning of the the optical lens?
You mean like the skeleton of the structure? You mean whole skeleton?
Yeah, because
You said the optical. You're talking about the experiment or the frame of the satellite?
the frame of the satellite, but what I meant by optical lens was, so we have, it's like a camera.
Yep.
Yep. Surrounding that, because bamboo could almost help that, I feel. Well, I am wondering, could bamboo help that to stabilize and like move it in the proper directions with the propulsion that we use?
Right. Again, that really comes down to the optics on our satellite are very sensitive, just like any satellite in space. It's extremely sensitive, even to the gassing properties of aluminum. So, and that's a question directly to NASA.
Yeah.
So, a couple issues that I have with how it might not work. First, you got to think of, can bamboo survive in negative 40 degrees Celsius up to 80 degrees Celsius of temperature and not lose its rigidity? That's the main thing. If you're going to be holding optics, we don't want to send a piece of bamboo up there and it melt or freeze and crack and break, as compared to using aluminum. So temperature is the first thing. Second thing I got to think of is thermal outgassing. You have a piece of live material that has micro pieces of gas inside of it, in the xylem and phloem of the bamboo plant. You have water that's moving through a bamboo plant that holds a lot of water for a long period of time. It's what makes bamboo so resilient to people that don't water it. It holds water very well. And so you got to think about if there's little bubbles inside of that, will those bamboo pieces just explode in a vacuum outside of the bamboo plant? Now you have an exploded bamboo plant, which could now get us in trouble with NASA because now we have an explosive on our device inside of their rocket that's exploding pieces of bamboo as it flies into orbit. It can throw off the mast, it can throw off a lot of other stuff. So those are the two things that I would definitely look at, is that you're sending bamboo into a very harsh environment, into an environment where everything inside of it is going to want to go away from it. So, you have anything inside of it that's liquid or of a higher pressure than the thermal vacuum of space. If it has a hole in it, air pockets in it, it's going to want to go out. Okay. And then you also got to think about that temperature piece, because if we're going to put an optic on it, it's going to be varying temperatures. Within 90 minutes, it will go from negative 20 degrees Celsius or 40 degrees Celsius to positive 60 degrees Celsius in 90 minutes at a time, continually, in, out, in, out, in, out. And a piece of metal can withstand those changes, I think, a lot better than a piece of bamboo can. And then the last thing is, how are you going to lay out that piece of bamboo? So how are you going to get the specific dimensional specifications that you need for that component? Like, are you going to would you take a giant chunk of bamboo and kind of chisel it down? Or would this be kind of like you take the bamboo pieces in the cylinder and you cut them in half, lay them out, flatten them, and epoxy them together with some type of aerospace grade epoxy? And then you seal it, and then you got to figure out different ways about how you're going to meet the dimensional analysis. So it's a lot more moving parts with the bamboo piece. So I would definitely spend some time doing the research on it. Saying can bamboo survive the environment of space and low Earth orbit, and maintain all of its key components that you find on Earth. Anything else? No? Okay. Do you want me to go over those pages again to look into for the manual, or do you have them?
I wrote them down.
Okay, and that NASA standard, you have that manual as well? Okay. Alrighty then. Well, folks, thank you, Jimena.
Thank you.
Thank you.
Thank you.